All right, physics. Hey, sorry about the audio issues in that first primer video for the lab. It cut out at the end, and it's when I started switching between all those different VLC windows. And so hopefully I can just fix it. We were basically at the end, I just was giving some tips on how to kind of start thinking about setting up your lab. And it all centered on this equation. And this equation, it can find the velocity of a projectile. In my case, it was a Nerf dart. In your case, it could be another Nerf dart, an airsoft BB, like a marble launcher that you make, a spit wad that you shoot, a pea that you shoot out of a straw, any projectile that could safely, and this is the key, safely be launched into a ballistics pendulum. And the ballistics pendulum could be much bigger than the ones that are shown on the video. So I showed a little cup, but if you are, say, throwing a tennis ball as your projectile, maybe you have a bigger cardboard type box ballistic pendulum with padding inside. But the key thing is you need to slow down the projectile enough that it stays as part of the system as it swings. So this equation, right, the muzzle velocity of the projectile is equal to the total mass. So this is the basically the dart plus the pendulum divided by the mass of the projectile times the square root of 2g times the change in height. Okay, 2g delta h, where delta h is easiest to measure, especially if things twist and turn. It's easiest to measure from the center of mass. So you're going to do your best job to estimate the center of your ballistic pendulum and record or come up with a clever way. Maybe you have a brave volunteer hold their hand above where you think the pendulum's going to go and they see if it touches their hand. Okay. Or you set up some kind of a trip line that maybe you could measure and determine if it's gone that height. You could see something move or make something tip over if it reaches that height, and then you just do multiple trials, and then you know the height that it gets to. So you got to get clever. So, anyways, that's the formula. But I want to show you a couple videos. Let me start this up. So I had some issues. You'll see. Here's the cup that I showed in the video. Now that worked. Let me slow it down. That worked pretty good. You can see maybe I'm center of mass is right there, and I get about an inch travel, maybe a little over an inch, I don't know. Again, you could do your best to estimate. If you're really technical, you could get a pixel counting extension in or on your computer, some type of app, or maybe you want to look at freeze frames and count pixels with some type of Photoshop or image editor. That's one way to do it. Or you could just set something behind it like a ruler and do your best to estimate the height. Again, this is more for learning. It's not for scientific publishing. We're not going to publish these values anywhere. So the goal is to find the velocity, in this case, of a pea. Now, I had to switch to the smaller cup because at first I used a large cup. Okay, this was from my Nerf dart. You'll notice I'm standing really far back also. So here's a tip for you. When I first did this, my first trial, I stood up really close, just like I had with the Nerf gun. I had the cup really close to the Nerf dart and I just fired it and I had no problem. But when I did that with the straw, my muzzle blast hit the cup and the cup went crazy. Like the cup almost swung up to my ceiling and I realized, oh crap, I'm just pushing air out the end of the straw, and that's adding an impulse. Okay, it's adding more momentum to the system. Not good. I just want only the P to hit it. So I stood like probably, I don't know, 4 or 5 feet back and had to aim. It took me a couple tries to hit it, but then I didn't have the effect of the air. So that would be something I'd talk about in my lab report. Okay, but here you go. The cup was so heavy that I could not accurately measure a change in height. Okay, not a very good one at least. So I decided I was going to lighten up the system so that I would get more change in height, right? Same projectile velocity, same energy here, but because the cup I made lighter by cutting it in half, I got more travel. Another clever way I've seen people do it, you can research this online. I'd be very impressed. This is an extension, and had we done it in class, probably would have you do this. You could tape a protractor up here. If you tape a protractor up along the string, you can measure the angle that it changes, okay, or that it swings to, and you can do a little trigonometry. I think it involves, right, a cosine. You can find the height that the cup moves based on the angle and the length of your string. So that's an option too. If you want to research how to back out change in height from string angle, and that's kind of a cool exercise. I would probably have you do that if we were in class. But anyways, this was my first try. You can see not a big change in height. So adjust. Be good engineers and adjust as necessary. This is not about getting it right on the first time. I rarely get it right on the first time, as you guys know. So not a bad thing, because you learn a lot in this process. And I can show you one more video. Let's see. I think that's it. When I did the Nerf video, let's see if I got this one. Yeah, the Nerf video had no muzzle blast. You'll see that the Nerf dart did fall out at the end, but at least for the change in height, the dart stayed intact. So I had to adjust the tissue paper inside enough to get it to stay and to catch the dart, but you could be very creative. You don't have to use a cup as the ballistic pendulum. If you can safely launch something sharp, not saying you should do it without parent permission or do it dangerously, you could use a potato as a pendulum, and you could, if you had a cool little like miniature bow and arrow or something that could shoot some skewer, you could shoot something sharp into the potato and have the potato just hold right that object and swing up, and you could measure the change in height of a potato. You could call it your potato pendulum lab. So again, this was just some ideas that I had. You don't have to use a Nerf gun. You could throw objects at it. Another thing, maybe you have one of those handheld Velcro games where you catch the like tennis ball on a Velcro pad. Maybe you hang that from 2 strings and you toss a ball, or you come up with a way to launch the ball, and you launch the ball. You try and do this as horizontally as possible. That's one thing. But you launch the ball and it sticks to the Velcro and it swings up as a system. Okay. Or maybe you come up with a really big object. You tie ropes up to a swing set you have outside, and you throw a heavy object at it, like a basketball or something, and you've got big pillows inside to catch the basketball. Again, creative is more fun anyways, so that I don't end up having to look. It's more fun for me. I don't end up reading the same lab reports and seeing the same results over and over. So try something fun. A Nerf gun is a good option, and hopefully this helps. If you guys have questions or you want feedback on some of your ideas, let's talk about it on Wednesday and Thursday. And then this lab will be due. We'll talk about the write-up, but it'll be due early next week. So like I'd say Tuesday of next week. But I'm excited to see how creative you can get. And the goal, okay, remember the whole purpose, it's called an objective of the lab, is to measure the muzzle velocity of a projectile. The velocity that a projectile is leaving, okay, that Nerf gun or that pea shooter or your arm, that's called the muzzle velocity, especially in gun language. And ballistics pendulums were ultimately probably created to help measure the muzzle velocity of rifles and things like that. So it is an important piece of technology, and we still use them, right? They're still really useful, but they've been slightly replaced with chronographs and other electronic speed measurement and ultrasonic measurement. So anyways, give it a shot, and I will talk to you guys later. Bye.